They titled Lesson 12-6 Statistical Measures. We're going to look at the measures of central tendency that we've seen before, mean, median, mode, and range, and measures of variation, which are going to be variance and standard deviation. What statistics should a teacher tell his class after a test? On Mr. Dent's most recent Algebra 2 test, his students earned these scores. When his students ask how they did on the test, which measure of central tendency should Mr. Dent use to describe the scores? What story does he want to tell? Is he happy with them or upset? He could tell both stories. Data with one variable, such as the test scores, is called univariate data. Sometimes it is convenient to have one number that describes a set of univariate data. This number is called a measure of central tendency because it represents the center or middle of the data. The most commonly used measures of central tendency are the mean, old average, median, middle of the list, and mode, most often. When deciding which measure of central tendency is to use to represent a set of data, look closely at the data itself. The mean, you're going to use that if the data are spread out and you want an average of the values. Median, the data contains outliers. The median will ignore outliers because you're only looking at the middle of the list. Mode, the data are tightly clustered around one or two values. The mode will help those stand out for you. A new internet company has 3 employees who are paid $300,000, 10 who are paid $100,000, and 60 who do all the work who are paid $50,000. Which measure of central tendency best represents the pay at this company? Since most of the employees are paid $50,000, the higher values are outliers. So an accurate representation, you'd want to use either the median or the mode. Now, which measure of central tendency would recruiters for this company most be likely to use to attract job applicants? They want to use the mean, which is $67,123 to make the employees look like they'd make more money. Bait and switch? Maybe. Measures of variation or dispersion measure how spread out or scattered a set of data is. The simplest measure of variation to calculate is the range, the difference between the greatest and least values in a set of data. Variance and standard deviation are measures of variation that indicate how much the data varies or differs from the mean. To find the variance, which is written sigma squared, of a set of data, follow the steps. Find the mean, and that's red bar x, or x bar. Find the difference between each value in the set of data and the mean. Square each difference. Find the mean of the squares. The standard deviation, which is what we're most interested in, is the square root of the variance. This is not a job to be done without the calculator. So first we have to calculate the mean, which is abbreviated on there x bar. And we're going to take each value in our data set, subtract x bar, square it. Find that sum, divide by the number in our data set, and then finally take the square root of it. Need a calculator. This table shows the length in thousands of miles of some of the longest rivers in the world. Find the standard deviation for these data. First, you need to find the mean. Add up our data and divide by the number of pieces of data. We're only doing 5 because it's a lot of work to do this by hand. So using a calculator, we get the mean to be about 2.85 thousand miles. Now the fun begins. We get to find the variance. We're going to take each one of those pieces of data, subtract the mean, square it, and then we'll divide by 5. Good order of operations on your calculator are essential. So I get about 1.104. So to finally get the standard deviation, I'm going to take the square root of my calculator, and I get 1.05. And that was in 1,000 miles. Each step is pretty easy, but you need to take your time and do it well to get it to come out right. To represent a set of data, use the mean if the data is spread out and you want an average of the values, the median when data contain outliers, or the mode when data are tightly clustered around 1 or 2 values. Standard deviation for n values, we're going to take the difference between each set of data, piece of data, and the mean, square it, add them together, divide by how many we have, and then take the square root.